The law of sines states that the ratios sine of angle A, here we have an angle A, over its opposite side, and here's our side A, and the sine of angle B and its opposite side, and the sine of angle C and its opposite side are all equal. These ratios are all equal. And we can put the sine of the angle on the top of these ratios and the sides, the opposite sides, on the bottom, or we can put the sides on the top and then the sines of the corresponding angles on the bottom. Now, how is this useful? Well, this is useful whether we have a right triangle or not. We are to use the law of sines to solve for all possible triangles that satisfy the given conditions. So side A of our triangle is 33. So if this is angle A, side A would be here, 33. Side C is 46. So if this were angle C, then this side would be side C. And we're told that angle A is 39 degrees. Now, sometimes it's possible for us to have two triangles that would satisfy conditions. And that would happen if we could maintain these three components of the triangle and still draw another triangle. So if we could imagine maybe breaking this triangle here at this angle and then swinging side A over and still allowing for a side of 33. So in other words, if we could still have this same angle, 39 degrees, but side A might come down this way and still be 33. And this angle remain at 39 degrees, and this side C remain at 46. Then we might have another angle C and a different side B, or angle B and side B, than what we have in this triangle, and still wind up with valid triangles where the interior angles sum to 180. So, if we are to solve these triangles, then what we should do is specify each of the angles and each of the sides for two triangles, if this is the case. But first we'll have to check and see if it's even possible for us to have two triangles. Now, why would it be possible using the law of sines? Well, something that we have to remember is that the inverse sine function is only defined from minus pi over 2 to pi over 2. So the right half of the circle. The sine function is positive in the first quadrant. So if we use the inverse sine function and we get a positive angle, then we know that the angle is in the first quadrant. But we have to remember that there's another set of angles whose terminal side is in the second quadrant that have the same sine value. In other words, the y components are the same for these angles. So what we need to do then is start to solve the triangle and then see if a second angle that we would find after we use the arcsine function on the calculator, see if that second angle, that second possible angle, would allow for a sum of 180 degrees in a second triangle. So we will begin by solving for angle C. So we'll use the form sine of C over C equal to, and then the other thing that we know is angle A, so we'll have the sine of A over side A, which we know. So we'll have the sine of C over 46 is equal to the sine of 39 degrees divided by 33. Now we'll solve for angle C. So we'll multiply both sides by 46. And we'll have the sine of C is equal to 46 times the sine of 39 degrees divided by 33. And then we will use the arcsine function. So C is equal to the arcsine or inverse sine of this ratio. 46 sine 39 degrees divided by 33. The first thing we should do is check to make sure that the calculator is in degree mode. So we'll hit mode, and then we see that it is in degree mode. So we'll hit second quit, and then we will hit second sine. So we have this inverse or arcsine function, and then we'll type this whole ratio in here, 46 times the sine of 39 degrees. Close that parenthesis, divided by 33, close that parenthesis, and hit enter. So we found that angle C is 61.3 degrees. Now, is it possible that we have a second triangle? Well, the other angle in the second quadrant that would have the same sine value as the angle 61.3 degrees would be the angle 180 degrees minus 61.3 degrees. And that will give us 118.7 degrees. So the question remains, is it possible for us to have a second triangle? Okay, so if we fill in the parts that we know so far for the first possibility, we have 39 degrees, which we've been given. We found an angle of 61.3 degrees. And then combining these two and subtracting that from 180, we would find that the third angle would be 79.7 degrees. Now, the other, if it's possible for us to have two triangles, then in this other triangle, we would have, again, an angle of 39 degrees for angle A. But then this time, angle C would be 118.7 degrees. And then combining those two and subtracting that from 180, we would wind up with 22.3 degrees. So since that sum, 39 degrees and 118.7 degrees, added to something less than 180 degrees, then we do have a second triangle. If that added to something greater than 180 degrees, then there would be nothing left for the third angle, and therefore there would only be one triangle. Now we'll fill in the rest. We know that side A is 33 and side C is 46. And that'll be in both triangles because that's given. And then the only thing left to find will be side B, which we can use the law of sines again to find. B divided by the sine of 79.7 degrees is equal to A, 33, divided by the sine of A, 39 degrees. And so B then will be 33 times the sine of 79.7 degrees divided by the sine of 39 degrees. So typing this into the calculator then, we would have 33 times the sine of 79.7 degrees. So sine 79.7 divided by the sine of 39 degrees. So this gives us 51.6 for the remaining side on this triangle. Then we would perform that same function again, only this time we would use 22.3 degrees for B. So for the second triangle, we would have B equal to 33 sine 22.3 degrees divided by the sine of 39 degrees. So we have 33 times the sine of 22.3 degrees divided by the sine of 39 degrees. And that will give us a value of 19.9 for side B in the second triangle.